Hello, my name is Anna Kipp, and this is my lesson plan video presentation. Ahead of this presentation, I wanted to note that since I do not have a smartboard, I will be presenting the PowerPoint presentation I made on my laptop, whereas if I did have a smartboard, I would be writing the answers on the smartboard as I worked. Here, I will just be pointing, and I have a secondary slide with the answers written on it. I also want to note that since I do not have an actual graphing calculator currently, I will be using the calculator on my phone. And since I do not have physical copies of papers to hand out, I will have the digital copies on the presentation for reference. And I would have handed those out to the first person of each row to hand back. Additionally, I also wanted to note that students would be paired for partner work by ability so that those who struggle with reading can work with someone who is a little bit stronger in that area to help them succeed. Okay. Hello, class. I hope you're all doing well today. And I hope everyone has had a chance to follow the class opening tasks that I've put on the board. If you haven't, please do so at this time. And yeah, so what I wanted everyone to do was to pull out their graphic organizer and graphing calculator and have them on hand for practice problems we'll be working on later. I also would like one person from each pre-assigned group to have come up and grabbed two whiteboards and two markers for partner work later. And anyone who uses a laptop usually in class, you know who you are. Please feel free to go and grab one from the back. Okay, to start, triangle congruence lesson. Okay, so who here knows anything about triangle congruence? Or has anyone here heard of the Babylonians? Yes? Probably in your AP World History class, regular World History class, maybe know a little bit about them. Well, did you know that it's recently been proven that the Babylonians actually were working on triangles and like Pythagorean's theorem before Pythagoras by like a couple hundred years? That's kind of cool, right? I mean, what do you think they were maybe using them for? Anyone? Well, they were actually using them to determine crop layouts and like how to farm. It's kind of interesting, right? Well, we're not going to be doing that, but we are going to be working on triangle congruence problems today and kind of tying that into what we've previously discussed on triangle identities. But to start, so today's objective, given your graphing calculator and the Pythagorean theorem formula that you have used in previous years and just your general algebraic knowledge, the student will correctly prove congruency of a pair of triangles using algebraic calculations and geometric proofs I'm going to have you guys do 3 problems on your own. That's all you guys got to do. We'll do a couple extras in modeling and partner work, but 3. Okay. I also wanted to tie this back into the state standards so you guys know and are aware of this because state testing. But knowing this, the student given information in the form of figure or statement will prove 2 triangles are congruent using algebraic and coordinate methods as well as deductive proofs, aka our geometric proofs that we discussed in previous classes, having to do with triangle identities, and then the ones that you read on your assignment, your graphic organizer from last class, the end of last class. So why do you need to know this? Well, you need to know this, 1, to finish out the rest of this series of lessons on triangles. 2, this will come in handy for solving real-world problems down the line, but also in the next couple of years when you take trigonometry and those classes. So, as you all probably are aware, this is page 1 of your graphic organizer. If anyone has any other questions about this, feel free to ask. Otherwise, I'm going to move on to review page 2, which was the new stuff, or new material for this lesson. So these are the postulates / proofs of congruent triangles. So the first one is side, side, side. So that is when you have all 3 sides of the triangles are congruent, and you can prove that they are equal. The next one is side, angle, side. So that is when you have 2 sides that are congruent on a triangle, and the angle in between them is also congruent. And by knowing that information, you can prove that these 2 triangles are congruent. The next one is angle, side, angle. So that is when you have 2 angles and the side in between them are congruent, like this. And the final one is side, angle, angle. So this is when you have 1 side and 2 angles, but the side is not in between the 2 angles that are congruent. So you have this side, and then you have these 2 angles are congruent on this triangle. So you can prove that this triangle is these 2 triangles are congruent to each other. Does anyone have any questions or need me to go back over something if I was speaking too quickly? But otherwise, I'm also going to do some problems so you can see me work this through myself. And I'll talk through my process to you. Geometric proof demo. So, given this first problem, I'm going to view it. Given triangle ACB, I want to prove that it is equal to DCB. Okay, so the information that the problem gives me to start is that angle BAC is congruent to angle BDC. So we have 1 congruent angle so far. And then that BC is a bisector. Well, if we flash back to our last couple lessons on triangles and their identities, we know that a bisector is one line that is perpendicular or splits. It is perpendicular, but it splits another line in half, so you have a midpoint. It is a bisector. So, by that information, we can conclude that line AC is congruent to line CD. But the other thing we can prove by that, since it is a bisector, it means it's perpendicular, which means both angles on either side of the line are congruent because they're 90 degrees. And it splits the line, which we know a line is all the way around is 180 degrees. So 90 plus 90, 180. And by that, we then have an angle, a side, and an angle. So if we go back to our proofs, angle, side, angle, and the side is in between them. So by that postulate, we can prove that triangle ACB is equal to triangle DCB. Does anyone need me to walk through that one again? Okay, then we will move on. So, next triangle problem we are going to prove using algebra. So, stuff we learned in previous years, finding the value of x. So what do we all know about triangles and their angles? That they're all 180, add all three up and it's 180 degrees. So then by that knowledge, we can then conclude that for this triangle, and this is how I would start this problem, this triangle is 180 degrees. So then I know that 65 and 55 are the other two angles. So then I would take using my calculator, I would take 180 and minus 65 and minus 55 to get 60. So then I know that this angle is 60. Well, I also know that if this angle is congruent to this angle, and this angle is congruent to this angle on these two triangles, then knowing that 180 degrees is the sum of all three angles of a triangle, I can then conclude that this this angle is 60 degrees as well. So then, how would I set up my algebra problem? Anyone have any ideas or want to take a stab at it? Maybe I can walk you through how I would do this. I would take this one and I would take 2x plus 30 equals 60. So then I would go and I would subtract 30 from each side and get 2x equals 30. And then I would divide both sides by 2 to get x equals 15. So the answer to this problem would be x equals 15. And by that, I then have all three angles of the triangle. Okay. Next, but also want to preface, just because we know all three angles of each triangle, that doesn't actually prove the triangle is congruent. Because there is no postulate, if we go back to there's no postulate that says angle, angle, angle. So we can find the value of x, but we can't prove those two triangles congruent. Does that make sense? Okay. Next, we are going to move on to practice problems. Okay. So everyone, pair up into your partners, pull out your whiteboards and your markers. I want everyone to attempt the problems I'm going to put up on the board. I'm going to be walking around. If anyone has if you and your partner get stuck on a problem, just raise your hand. I can come over, try and help you out, see where maybe a step is missing, maybe advise on another approach to start the problem. Otherwise, what I really want you guys to also focus on with this is discussing. So maybe both of you attempt one of the problems. Maybe one of you figures out, maybe one of you doesn't. That's not really the most important part of this. What I want you to focus on in this part of the lesson is to talk it through. Talk through the steps. Talk through how you're approaching the problem, and if you guys both solve it, how you got your answers, what your answers are, that. Okay? Here are your problems. Walking. Students will be given a few minutes to work on these together. Take about 5-10 minutes, kids. Flashing forward 5 minutes. Okay, to run through these problems with you guys. So, for problem 1, given that DE equals FG and AC equals CB, and then that EC equals FC. So, how do we prove this problem? Well, we know that this line equals this line, and this line is congruent to this line, and this one is congruent to this one. Well, first step of how I would approach this problem would be that you know that these two sides are equal. By knowing that, you then know that EF is the same as FE by the reflective property. Therefore, we conclude that DF is congruent to GE because DE is also congruent to FG. Does that make sense? Little roundabout thinking, but you get there. We can also then conclude that AC is congruent to, AF is congruent to BE by the same way, because you know that AC is the same as BC and CF is the same as CE. Make sense? Given that, then we can then conclude that these triangles are congruent. The next one is what postulate or theorem can be used to prove triangle EFG is congruent to IHG. So, what theorem or postulate could we use to prove this? Any ideas? Currently, we have a side and an angle marked out. What can we do to prove this one? Well, we also know that knowing that these are both right triangles, we know that that means the angles, this angle will have to equal this angle, and this angle will have to equal this angle, because right triangles are a special circumstance. If we flash back to our triangle properties, they are a 30, 60, 90 degrees. Cool? So then you know that you have a side, an angle, and an angle. Or a side, an angle, and an angle. So then you can prove by angle, angle, side, yes, angle, angle, side, that these two triangles are congruent. Next one is another find x. So for this one, you have two angles determined on each triangle. So, knowing that each triangle is 180 degrees, you can take your calculator and you can take 180 minus 69 minus 50, and you get 61. So 61 would then equal 2x plus 5. So, does anyone want to take a stab at how you would set up this problem? That is correct. You would say 2x plus 5 equals 61. Okay, what was the next step you would do? Correct, minus 5, plugging into my calculator, get 56. Then, anyone want to take a stab at the next step? Yes, divide by 2. Calculator, 28. So, then we know that on this equation, x equals 28. Okay, next, I'm going to hand out some papers to everyone in the front row, and I want you to pass them back. Everyone take one. You have 5 problems on this. All you have to do is solve 3. This is just independent practice, just to see what you retained. On your own, see if you can walk yourself through these problems. You can answer 3, and if you get through all 3, then attempt the last 2, just for fun. Extra credit, see what you can do. This is the last. So this is the digital copy. For anyone on a laptop, you will have the digital copy already preloaded into your files. Okay, and then your extra credit problems. So prove the following triangles congruent using either geometric proofs or algebraic means. You can use your calculator, and everyone can use their graphic organizer of their proofs as reference. Okay, take the rest of the class to do this, except for the last 5 minutes, then we're going to do a quick exit ticket. Okay, we're on to the exit ticket. I'm going to hand this out to everyone as well. So, just hand this in by the end of the class. We're going to take 5 minutes. Okay. Switch with your partner, and you're each going to just grade each other's exit ticket. Doesn't count towards any final grades, just practice. So which postulate or theorem can be used to prove that ACB or ABC triangle equals BAD? Well, for this one, we know 2 angles, but we also know that these triangles share a side. So then we have angle, side, angle. Cool. Next one, value of this one. Does anyone have any guesses? Anyone want to take a chance? Yes. Yes, you are correct. Because we know that these 2 sides are equal, we know by knowing our triangles and their identities, that this is an isosceles triangle. Therefore, because it is not equal to the final side, is isosceles, so then we know that 70 degrees x equals 70 because those two angles would be congruent by isosceles triangles. Okay, and the last one, don't have to share this one. This is just a freebie, but please hand in your exit tickets or leave them on your desk, and I will come around and collect them at the end of class. But have a good day, everyone, and you are free to go. And that is my lesson.